Okay. Hello, everyone. Audible, everybody? So basically, we met yesterday. So I guess you remember. My name is Moinak Majumdar. I'm working as a technologist at Tata Steel Limited. So yesterday we spoke about basically what we can do with AI after we get the data. Right. So that is what comes in level two. So we went past level one and then we went to level two basically. So right now we will be focusing on how we can get the data because unless you have the data, your AI models are basically useless. So that is what we will see today, how we handle it in any industry or data sheet specifically. And I'll show you one example where we have like developed our own vibration sensor from scratch. So we got award for that also, and yeah, we'll come to that. So okay, so I think from day one you are hearing about the term IoT. Can anybody tell me the full form of it? Internet of Things, correct. Can now I want to ask like what it is. What is Internet of Things? Just maybe just one line. Means what do you understand by Internet of
Physical things connected to internet.
what things? I'm sorry.
Physical things.
Physical things. By physical things, what do you mean by physical things?
Machines.
Machine. Okay.
Devices, sensor, actuators.
Oh, good, good. Okay, yes, correct. So basically, devices, sensors, everything, even your smartphone is basically your IoT device for. So basically, what it means is like there is a whole ecosystem of it where you can like from the internet you can access a host of devices. Okay, so that is what we called as IoT. So there are a lot of definitions of IoT you can find. I guess throughout the your session you will come to know like what is IoT. You will change one by one what IoT means. You will learn more about it. Okay, so basically IoT for me is basically that a lot of devices is connected to one network and one device can be connected to the other device using that network itself. Okay, so basically, if you give a signal to the internet, it will come back to one more device and it will actuate that devices. Okay, so like you can see, IoT is a sensor network of billion of smart devices that connect people, systems, and other applications to collect and share data. Okay, so you see the word whenever you see IoT or whenever nobody says IoT, everybody says smart devices. So why is it called smart? So you might have wanted to know why is it called smart? Why not anything else? So basically, smart here is basically a term that people use to like sell their products. Okay. So smart in the sense here means that to have one device, you can control it without any human interaction. So basically, that's what makes the device smart. Okay, moving on. Maybe why IoT? Yeah, why do we need IoT in our industries? So you see, let me take example of our Tata Steel itself. So in Tata Steel, there are about lakhs and lakhs of machinery, and you cannot like go in person and check whether that machine is working or not. When does it need a maintenance? You cannot do that. So that is the time when like you can put sensors on it and that sensor will send the data to cloud and from the cloud you will create a dashboard and from the dashboard from a central location you can sit at your own location in an AC room basically and you can watch all the lakhs of sensors that are connected. So basically that is why organizations need IoT. One more reason is that suppose there is a series of production happening, right? So in between, if any one machine stops, the whole production stops, and we will be facing huge losses. So to better efficiently run the factory, basically, we would need this IoT or the connected devices, so that we can monitor everything, we can plan ahead of everything, and we can make basically what we call as a smart industry or a smart factory. Okay, we'll come to that later. Okay. Next is what is an IoT ecosystem? Just as I mentioned, as all of you have also said, that basically it's a host of sensors and everything that is connected to a whole cloud platform, and from there we can, like, from a remote location we can check what is happening to those sensors and everything. Okay. Next is okay. This I think everybody knows what are the benefits. It's like monitor everything, improve customer experience, correct, save time and money, enhance employee productivity, integrate and adapt to business models, make better business decisions, and generate more revenue. Generate more revenue mostly comes like to cut costs and everything. Okay, now we focus on, see IoT basically can be called as, there are home automations also, like remember when we used to go for any vacations, when we step outside our house we used to think, did we switch off the stove, did we switch off the lights and everything, did we switch off the geyser? We used to think like that. Right now you don't need to think about it, you simply walk out of the house. If you have not switched off your lights, simply you can check from your mobile app or anything, and maybe it will tell you that yeah, you did not switch it off. You, at the click of a button, you can simply switch it off. So it's that easy right now. Okay, let me show you one example of home automation maybe. So basically this is what home automation means actually here. Okay, so, oh, it's not visible. That's right. See, this is the basically what the gateway I am talking about. So this basically all the signals and everything come to this, and from there all the other devices that are connected to it can be controlled. Okay. So at 6 o'clock, basically the alarm sent a signal to the gateway, and from that signal it came to know now I have to turn on the lights. So basically it is turning on the lights. This is the remote. So basically, this is your what you call as a magic wand. Basically, you just wave it and everything happens in your home literally. So this was basically a part of how home automation actually looks like. Uh, so yeah. So now maybe we move on to in industries, where and how do we use like where can we use IoT in industries. In basically, I will speak about mostly from my experience at Tata Steel, basically. Um, so yeah. So what is industrial IoT is basically the number of sensors that you connect basically at level one. Level one means basically at the ground level on the machines. Basically, you have lots of motors, you have different kinds of gearboxes and everything. On that, you have to monitor those products. So monitor those equipments basically on cranes. So there are a lot of cranes that are working, overhead cranes. There are line cranes. Every cranes there are. So you have to monitor all of those devices or equipments basically. So what you can do is put a sensor, some kind of sensors on it, and that sensor will send a signal, and from that gateway, means that signal you can receive it at a gateway, and that will send it to the cloud, and from the cloud it will come to your dashboard. Simple as. So basically, then yes. So in industrial, basically what the concept we try to bring is a connected factory leads to a smart factory. So basically every industry now wants to make it as a smart factory. So how can it make it? By connecting the whole thing to, and we can monitor it through a single place. So that is how we make it as a smart factory. Okay. So in manufacturing industry we can use it as, again it's the same thing what I said, the IoT sensors, how you connect it, and then you can monitor it. So how it helps basically in our manufacturing is helps us in planning ahead basically. So we know when equipment has to be maintained, needs maintenance. When do we need to stop? When can we plan the shutdown? So during shutdown we face losses. So a shutdown cannot go for more and more days because we find new and new equipments that need maintenance. So we know from beforehand only that we need some 100 equipments require maintenance. So we will simply just take one shutdown for 5 days. We'll maintain all the equipments and the factory should start as soon as possible. Okay. So yeah. So now there is a very important aspect here basically. Uh, the challenges that we face when we use IoT in uh, industries basically is security. I think somebody from the audience recently asked me. So how do we handle security at Tata Steel basically? Okay. So basically, what happens? Our data basically goes to a Google Cloud platform. Ultimately, before that, there are intermediate servers where we keep the data, and from those servers, the data is taken to the Google Cloud platform. So basically, that Google Cloud platform can only be accessed to those devices or laptops or mobiles, whatever, those who are connected to the Tata Steel intranet, not internet. So Tata Steel basically has his own intranet, and only those devices that are connected to it can get access to it. So that is how, and any third party that needs access to our data, or a certain part of our data has to sign a whole non-disclosure agreement, and there are a lot of formalities that needs to be done before they can access our data, even though it is told that we should not share data with any third parties, but sometimes it becomes mandatory or required to move ahead with any project basically. Okay. So as you can see, yes, it becomes vulnerable to hacker. We have firewalls, we have all kind of precautionary measures taken, but still there can be some lapses, maybe because of phishing, or maybe somebody clicked on an unknown email and the whole intranet became exposed. So those things we have trainings for that. We are being trained like to know which is a phishing email, how to identify which is a phishing email or any malicious email. So yes, but humans can make mistakes. So nothing is 100% basically here. Okay. So okay. So basically the topic for today, what I want to know. So that was basically a beginner like IoT. I think you are hearing it for a long time. So now it is in predictive maintenance basically. So what is predictive maintenance basically? Uh, is the same thing that I said. Like any machine needs maintenance. So how will we know when it needs maintenance and when it does not? Okay, so that is what we want to do with this predictive maintenance. So an equipment, we put a sensor on it that can be any kind of sensor, and that sensor will send you the data. Yes, and from that data, we will be creating an analysis. Like yesterday, we saw how we can make a AI model when the IoT or this connected networks was not there. We used to do traditional maintenance. Traditional maintenance means everybody used to go to the place to look after the machinery. We used to check the machine. We thought that okay, we don't require maintenance now. We used to come back within a few days, like 5 to 7 days, the machine used to like stop working. So why did this happen? Basically, we misjudged it. Okay, so we misjudged it. We thought that the device can work, the equipment can work for a longer period of time, so we did not make a maintenance. So that is what we call as under maintenance basically. So the schedules that we made may not be adequate. It was irregular, and that is why no maintenance was perfect during that. Okay, so then we did not have any sensors that sense data that we can analyze. We can make an AI model. AI wasn't there in the long back. Only AI wasn't. It hasn't even come yet. So during that time, we did not have that enough data to make claims that okay, this device needs this equipment needs maintenance or anything to be changed or whatever. Yeah, safety is a big concern, not in only Tata Steel but in every industry. So any machinery that has the parts worn off or anything can easily break, and that can just come out and can cause you a safety hazard basically. So you have to be very careful about this, and that is why equipment may fail and can cause safety hazard, causing problems for the people around us. Okay. So basically, these are like four reasons why uh, we chose to take a predictive maintenance over a traditional maintenance. So this is why we need a predictive maintenance. So first of all, everything comes as a cost reduction, basically. So cost reduction, like I said, like it helps us plan the downtime and everything. So by that we can reduce the cost of everything, or we can take more less people to do the work in lesser time. So minimize downtime, again same thing. So we don't need that much amount of time to solve like everything right now. So we know how much time we need to for maintaining a particular equipment. Okay, equipment reliability comes from the safety part only. So safety, because now the equipment is working fine, we have checked, we have greased everything, no part is worn off, the worn off part has been changed. So basically now we can be safer, we are in a much safer environment than what we were before. Okay, so how does IoT enable predictive maintenance? Again, it's the same thing. First is the deployment of the sensor, and we will get real-time data from the equipment. Then we will be checking with our connectivity. We have lot of connectivity, so maybe Wi-Fi is there, BLE, maybe Bluetooth Low Energy you have heard of. Then you could have heard of LoRaWAN, like I think Vasan sir has told yesterday, other speaker has told yesterday. LoRaWAN, that is a long range wide area network. So there are few communications we can use their connectivity for connectivity as well to the cloud platform. Okay, data analytics. I think we talked yesterday how we can how we can use the analytics, all the data that we have got, and we can put it into an AI model and how we can predict everything. Okay, so fourth point is the same thing what I have said. All right. So now, yeah. So what kind of sensors can we see in our at Tata Steel or any other industry with? So first I will talk about vibration sensor. So vibration sensor basically, as the name suggests, it detects the vibration of an equipment. Not in case of abnormality, but in any case, basically it will tell you the vibrations of the equipment. What we are getting. Okay, flow sensors are basically put in pipes basically to monitor the water pressure and the fluid rate, flow rates, if there are any blockages, if there are any leaks or not. Because we work at a place where we deal with hot metal basically. So what is hot metal? Hot metal is basically that's a molten steel. Okay, so if there is a single drop of water also, it comes in contact with the molten metals, so it causes a huge explosion. Okay, so there should not be any drop of water inside the factory or the plant. So we always need to check for leaks also. So that's where flow sensors come into things. Then is proximity sensors. So we have lot of wagons that carry coal from this location to the other location, maybe from the coke plant to the blast furnace and like that. So there are a lot of wagons that goes one by one. So if any wagon comes like very close to each other, it can collide with each other and it can cause a fatal accident as well. So to prevent that, we have proximity sensors that detects the presence of any other objects that is coming near or not, and that can stop it also. So we use proximity sensors for proper positioning and for preventing collisions. Okay, and we have sound or acoustic sensors. This is very interesting because recently we actually did one project actually. So what happens? I'll tell you a small process how steel making happens. Okay, so we get molten metal basically. Okay, so molten metal is basically you heat it in the blast furnace. I guess none of you have an idea about a blast furnace. So basically, blast furnace you can consider it as a big oven. Okay, where you cook the hot metal basically. So hot metal is molten steel basically. So that now you have to give it as a shape of a bar. Okay, you see the rods we get or the bar of steel we get. So that is how. So what we do is we have a mold chamber, that is a square shaped chamber we have, and that square shaped chamber we pour hot metal on it. Okay, there is a water cooled pipe that flows all around the walls of the copper plate basically, that four walled copper plates, and it cools uh, the mold basically. You know how eggshell is, like the egg is outside, there is a shell and inside it's still liquids in nature. So it's the same thing basically, the outside part first cools and the inside part still remains as a molten state, but as it comes down from the mold, it becomes cooler and cooler and then it takes a solid state basically. Okay, so now what happens, like when the mold is happening, like if you crack an eggshell, no, the whole liquid comes out of it. So in our case, it's not the liquid egg basically, it's basically the hot metal. If it comes out, it causes damage to all the equipments that are present there. Okay, so we have to predict that. So what happens? There is a water channel going outside it, right? So that water channel we have placed a hydrophone inside. So what is hydrophone? Basically, it takes up the sound that is happening inside water. Basically, so that's what hydrophone is about. So we placed a hydrophone inside it, and we are now picking up the friction patterns. Okay, if there is any crack, the friction pattern changes, and the hydrophone is picking up a different sound pattern, and then we know that there is some abnormality happening inside. So this is kind of a work in progress basically, but see, that's how we can use acoustic sensors or like hydrophones and sound sensors uh, to like protect to indicate potential malfunctions also. So these are only few examples, I'll give you more examples on the way, by the way. So yeah, data collection process of any deployed sensor. Like basically we put the sensor, we deploy the sensor on the field. Now what do we do? So what happens first is the comes the data sensor deployment part. Then comes the data acquisition part. That is already taken care by your PCB that is present inside. Then is the signal conditioning part. That means you get the signal. Then data conversion basically means like see, in our vibration sensor what we get it as a hexadecimal or as a binary um, input. So that we have to convert it into an acceleration value. So there are formulas that are already given by the makers of the vibration sensors. So that data conversion we have to do. Data transmission, basically you have to select your best possible choice. Is it Wi-Fi, is it Bluetooth, is it LoRaWAN, or whatever it is. Data storage, this is very important. You need a temporary storage or a server where you can place the data first, and from there you have to send it to Tata Steel Google Cloud platform basically. So once you send to Google Cloud platform, that is what we call as a secure data. All right. Then is real-time processing. I guess you understand that. Basically, that is what your dashboard is all about. Data analysis and visualization. Yesterday we talked about it. Anomaly detection and predictive analysis. Again, you have to train your model. You have to make them understand what is the defect and how you can predict it for the future purpose. Okay. And then there is maintenance actions that comes after you have predicted that there will be certain malfunctions there. And then there is continuous monitoring, so you continuously keep on monitoring the sensors that yeah, this is not working, this is okay, this is not working, this is it needs maintenance, etc. Okay, before we go to this case study, maybe I'll tell you few things, maybe the few projects that we have done. Okay, so basically I'll tell you one of the project. This this okay. So there are a lot of EOT cranes. Okay, so EOT cranes basically are overhead cranes, basically overhead cranes that there is a hook connected to it. It takes up weight and it moves from one place to another. Okay, so there are four types of limit switches. Okay, this I have shown just for an example. This is, there is a counterweight switch, there is a speed control limit switch, and there is rotary limit switch. There is everything. Basically, what limit switches does is it prevents the crane from overworking. Okay. So what happens? This counterweight switch that you see on limit switch that you see, counterweight is basically when the crane actually takes up too much load, this limit switch activates. This limit switch activates and it says that the crane will not work because you have taken up too much. Okay, there are different limit switches also, that so that it does not overshoot its position. So we have a position set for it. It should not overshoot that. So that limit switch gets activated when you overshoot that position. There are certain kind of. Okay. So what we have done as our project is we have made an IoT device that monitors all these limit switches. Okay. Whenever any of these limit switches activates, we come to know that something is wrong. So that the operator that is working there should know that I have taken on too much weight. Okay. So what we do is we take all the limit switch sensors. So switch is basically what? 0 or 1. So basically we take that signal 0 or 1 and then we send it to the operator. Okay, so we tell the operator that there is an alert. We actually send an alert packet. Okay, here what we have used LoRaWAN. Okay, so let me tell you a little bit about LoRaWAN. So LoRaWAN is basically long range wide area network. Okay, so it can cover about 15-kilometer radius basically. So 15 kilometer is a very big area that it can cover. Okay, so we have taken this because there are no gateway that we can place in between. That is the reason we have used LoRaWAN here. So there is limitations to LoRaWAN also. We can only send 50 bytes of data every 15 minutes. We cannot send huge amount of data at once. So that is the limitations of LoRaWAN also. So what we have done is we take 50 bytes of data. In those 50 bytes, we tell the operator that this limit switch has been changed, this limit switch has not been, no limit switch has been triggered, or some limit switches has been triggered. So that information we tell them. Next, we have a CO sensor. CO is carbon monoxide. So basically, in our steel plant, one of the byproducts you can say is basically carbon monoxide. As you all know, this carbon monoxide is basically a very dangerous kind of gas. That is, when inhaled, it can cause basically human death can occur also. So we have to like detect whether the like what is the concentration of the CO at a particular location. Okay, so you cannot. We have a portable CO sensors that we can take around, and we have CO sensors installed at every location in our plant. Okay, but people cannot go there and check, okay, here the concentration is more, because that will become a hazardous area for that person itself. So what we have done, we have made another IoT devices that monitors the ppm of the CO sensor, of the carbon monoxide sensors, and it gives it in a one dashboard. In one dashboard you can see all over the plant the number of CO sensors that are present. We have all made it in one place. So you can see the ppm or the percentage of CO at that location easy. So there is one more project that we are trying to do is, see, when a CO sensor, when carbon monoxide gas is formed, no. So with the wind, it moves from one location to another, and it's heavier than air. It's heavier than normal air basically. So it tends to settle down. So it tends to settle down and it floats like a cloud basically. Okay. So what happens? We know the locations of where the sensors are created in every plant location. We know, so what we will predict is like which CO sensors ppm is increasing, then decreasing, and the next CO sensors is increasing. With that, we will come to know that which wind direction it is going, and which CO, like where the CO cloud is moving towards. Okay, so this is again one example where we are using IoT. Uh, this one more as well is we are using for anchor bolt monitoring system. Okay. So in blast furnace, what happens when you create when you are making hot metal? Uh, so basically, there are air filled with it, and when you are tapping out the hot metal, there is a certain point where it creates a vacuum. Okay, so when it creates a vacuum, that whole structure tries to shrink. Okay, when it tries to shrink, there are bolts that are holding on together the whole structure. Okay, so what happens? This bolt usually, it is like in a straight position, but sometimes it bends like this. Okay, or it tries to come out. Okay, so that we are monitoring via LVDT. So LVDT is a linear variable differential transducer. So basically, any motion that happens is converted to an electrical signal, and we come to know that yeah, there has been some movement in the bolt or something. All right. There is one more thing that we are working on right now. Okay. This is what we called as an idler. Okay. So what is an idler basically? Have you seen the conveyor belts? Big conveyor belts. Have you seen those rollers? Anybody seen, right? So the all the belt that moves on, it moves through this. Okay, so these are conveyor belts. So there is a motor that drives the belt basically, and these just rolls on, rolls on, rolls. Okay, so we have few kilometers long of conveyor belt. Okay, to monitor all of these rollers or to maintain all of these rollers is a huge task basically. So how will we know that this roller needs maintenance or any roller needs maintenance? And if any roller stops working in between, the whole kilometer long of thing will just simply stop. And if it stops, you guess it, we will face losses. So what we have done, we will be monitoring it. Okay. So how will we monitor? We do not have a power supply here. Okay. But we have a rotating motion. This the black colored things that you see are rotating. Okay. And inside it is hollow. Okay. What we can do is we can harness this rotating power. We can feed it like a generator. You can use it as a generator, and we can feed it to a rechargeable battery. That battery in turn can power up our IoT PCB or IoT device inside it, and it will tell you the temperature, the vibration, whatever you need to do. Once you have powered up our device, you can put any sensors what you want, and then you can monitor it simply. So this is the idea that we are trying to do right now. This is a very good idea. We'll see if we can move forward with it. So this is what we call as a smart idea. Okay. Now we'll come on to the part where basically we got an award for it. So this is what we call as a vibration sensor. This device that you see is made from scratch at Tata Steel itself. So we have made it from scratch. The whole design, whole modeling, everything is done by it. The outer covering is made by a 3D printer. So with a 3D printer, we have printed the whole model. We have the step file, we have the design or the step file for it, and we have made this. Okay, so why is this used? Where is this used? In any kind of machinery where there is vibration and it needs to be monitored continuously, that can be used. Okay. So now, what have we used inside it, basically? Okay. Not before that, we'll see why we have made it, basically. So requirement was to monitor all the critical equipments. I guess you understand. Now selection of components, we have selected an accelerometer. You need an accelerometer to measure the vibration, basically. ESP32 board we have used. That is our microcontroller, and it contains the Wi-Fi module inside it as well. Excuse me. We have the PCB design also we have done from our side. We have a voltage regulator. From the voltage regulator, it goes and powers up the accelerometer and the other devices as well. It's a whole design of it. Okay. Now is the selection of the communication protocol. We could have used easily used LoRaWAN here, but why we did not use, or why we did not use Bluetooth? Or why did we not use SIM based? You know, SIM based. You can connect to the internet via a particular SIM. Why we did not use that? Why we use Wi-Fi here? So I'll tell you the drawbacks first. If we have used SIM based, we require about like lakhs of sensors we need, and then we need to purchase lakhs of SIMs for it. Okay, that does not seem feasible for us, so we cancelled the SIM based design. Then we moved on to LoRaWAN. So if we have used LoRaWAN, then we could have only sent 50 bytes of data every 15 minutes. Okay, but we need a huge amount of data, but at least like few kilobytes of data we need for vibration to be monitored. For analysis also we need huge amount of it. 50 bytes is not enough for us. So LoRaWAN is also cancelled. So we focused more on Wi-Fi because we can easily have a gateway there where our Wi-Fi will can easily connect to the internet, rather the intranet of our Tata Steel, and it can send the data directly to one of our servers and thereafter to the Google Cloud. All right. So realization of product, we assembled everything in our lab itself, and we made the product. We realized the product and we did it. Deployment of the plant in deployment of the device in plant. We have deployed many sensors in plant. It is in working condition as well for all the critical equipments. Sending and storing data at a centralized location. We are already doing that. Monitoring and maintenance. Yes, it's helping the maintenance team a lot. We have got feedback from them that it is being helped by them so that they can plan the maintenance now, basically. Data analysis and historical data we are doing, and I will come to that also, how we are predicting the failure. Okay. This thing is not visible, but I'll tell you how it looks. That part was our first design. I don't know why it is not visible. Um, it's too white. I don't know how. Why? Can you check once? Because in my screen it is fine. What's the brightness? Maybe I need to reduce the brightness of projector. Just see, it looks like this and it's completely white.
You can just put off this light also. This
Oh,
light of
light is off already, no?
This one actually. So there might be some reflection of light. When try. Light. Light will be very fine.
Yeah, हो गया, हो गया. Okay. So basically that was our first design. Okay. You might remember something like an Alexa, Amazon's Alexa. We inspired this we were inspired by this Alexa model and we made this. But we had to ditch this. Why? Because it was very huge. Okay. So it was big in structure, it was not fitting on all the machines. It was heavy, it was falling down, and this structure was not okay for us. So we faced with our first failure there itself in our design itself. Then after that we moved on to this design. So this design was more feasible for us. It is long enough. It is not heavy. Okay, the first base plate that we made it with stainless steel. Okay, that made it more heavy. So we understood that we cannot make it heavy, so we switched to aluminium. So here we switched to aluminium. We made this design, and basically this works now for everybody. This is lighter, fits properly with everything. So basically, this is the model that we have made. Uh, there, the PCB was flat. Okay, there was one more challenge. Is like the PCB was flat. There was lot of places, and we can place any component. When we made this, we had to make the board as rectangle. Okay, so when we made the board as rectangle, we faced with issues with placing the components in all. There are a lot of components that needs to be placed, and we faced issue with. But somehow we have a very competent team with us, and we managed to fit all the components that we need. We actually had to dig the temperature and humidity sensor that we were trying to put into it because there was no place for it. So if we had put that, there was actually we have to remove the vibration sensor itself. So that's not correct. So basically, this is how it flows. You see, from the machine, it takes the vibration. Our device takes the vibration, connects to via Wi-Fi, sends it to an intermediate server, or then thereafter to Google Cloud, and from Google Cloud, there is this dashboard that is being made. Okay, so in dashboard, we do a lot of analysis and everything that I will come to that later. Okay, so this is basically the algorithm or the flow what we have tried to do in our vibration sensor. So basically, first we will be initializing the sensor, then we perform auto scaling. Let me explain what is auto scaling. So auto scaling is basically our sensor what we have can measure in these ranges basically 2G, 4G, 8G, and 16G. So what are these basically? So as you know, for vibration we need an accelerometer basically. So accelerometer measures acceleration. Okay. So G means here 9.8. We consider it as a 9.8 G. 1G is 9.8. So 2G is 9.8 into 2. There are calculations based on that. So our device will give me vibrations in terms of G, basically. Now, why we need this auto scaling feature? A simple example I'll tell you. You have two scales. Okay, one is a 5 kg scale and one is a 10 kg scale. Okay. In 5 kg scale, if you try to measure 1 kg, you can see it as this big. Maybe this is a 5 kg scale. You try to measure 1 kg, you can see it this big. Okay. Now, if you consider a 10 kg scale and you measure 1 kg, you will see it only this much. So, which is better resolution? The 5 kg one, right? The 5 kg one will have a better resolution. So, according to our machine vibration, our device automatically takes the scale according to it. If it is maybe it sees like the vibration is like around 1G or 0.5G, it will automatically set the scale to 2G, 2G scale, so that we get a better resolution. Accordingly, it can set it. Okay. Then we wake up the ESP32. Okay, so ESP32 stays in sleep mode to conserve battery basically. So our is a battery powered device. We have two AAA batteries. Okay, two AAA batteries, and that powers up the our vibration sensor. So we need to conserve it. So we have a very interesting feature in ESP32 where the ESP32 can switch up and go to sleep basically, but it can suddenly wake up whenever it senses some abnormality. It is a very interesting feature in ESP32. So we have utilized that feature to make our components go to sleep basically. Once your work is done, just go to sleep. We do not need continuous data. We can take data every 4 hours, every 10 hours, 8 hours. Anything can be excuse me. So basically we wake up our ESP32 and we establish our Wi-Fi connection basically. So it searches for the Wi-Fi network. Suppose it could not find a Wi-Fi network. What will it do? It will not search for the Wi-Fi network throughout the entire time. Okay. It will only search for it 3 times. First time it searched, could not find. Second time, could not find. Third time, could not find. Go to sleep mode. We have to conserve battery. Battery is our main concern here. Okay. Next was initialize and open FTP connection. Okay, so what is FTP? FTP is basically file transfer protocol. Okay, so file transfer protocol, why we have used file transfer protocol and not HTML or not HTTP? Why we have been used it? MQTT is also there. Why we haven't used? There are a lot of debates about that. But for now, we found out that FTP is better for us. It creates a folder on the server itself. It creates automatically creates a folder, and in that folder, it will send the push the data itself. Okay. So FTP connection and the folder is created. So automatically, according to the timestamp, a folder is created. Okay. Okay. So our accelerometer is triaxial. So it measures the vibration in all the three axes. Okay, X, Y, and Z. Three axis. It measures the vibration. Okay. So then what it comes? So it collects the sensor data and it sends the data to that folder itself. It closes the FTP connection, closes the Wi-Fi connection, and puts the sensor in power down mode and goes into again deep sleep mode. So that is what we call as a deep sleep mode. It is already there in the data sheet of ESP30. So my suggestion is whenever you want to work with any component, any device, the best guide is basically the data sheet. Okay. Uh, so this is that. So these are some features that we have in our vibration sensor. So basically, we have a battery life of about 1 year because our data it is fairly fast enough. It takes only 5 to 7 seconds to only send the data. Basically, 5 to 7 seconds. It wakes up. It takes only 5 to 7 seconds to send the data. It goes to sleep. Simply. Okay, we have an auto scaling feature like I explained. Auto offset calibration. This I will show you with an example. Okay, what is auto offset calibration? Okay, and we have auto sleep mode and we send data with every 4 hours because that was the requirement from the people. Okay. We have set a sampling frequency of 6.4 kilohertz. That is basically sampling frequency is basically the rate at which the data is taken from the sensor. Why we have selected this? Because as you, I think you have all known like Fs is greater than equals to 2 times of Fmax. Okay, so Fmax for our maximum frequency we considered is 2500. Okay, 2.5 kilohertz basically, and we do it greater than equals to we multiply it with, sorry. So basically you have we multiply it into 2 and we get 6.4 kilohertz. Basically with 2.56 basically. Okay, so okay, this is very interesting for you. See, we had to test our sensor. Okay, so when we tested our sensor, we gave it a sinusoidal signal. Okay, of 1G vibration. 1G vibration, a sinusoidal signal we gave them, and we tried to find out how much we are getting. Okay, and we gave it a frequency of about 300 hertz. Okay, 300 hertz and 1G vibration. As you can see, we got a sinusoidal signal correct, but you see the peak value is only 0.8. Why is it not 1G? Why is it 0.8G? Okay, so we search and search, we had lot of research paper. So what we understood is the way we are mounting our vibration sensor, it's actually absorbing some vibration basically. And that is why we are not getting the correct value. Okay. This next, this part is what we call, we have done a fast Fourier transform of it. Fast Fourier transform of the above time signal graph. Okay, so first Fourier transform, I guess you all know. So you take the above graph. If it is like this, you just move the plane to the other side. Now you can only see one peak. Here you can see multiple peaks. If you move it to the other side, you can get only one. So here you can find the frequency there. The frequency you see it as 300 hertz. That is correct. Frequency we are getting very correct. Okay, but there is a lapse in the amplitude basically because it's absorbing some vibration and it has a very good pattern also. So we have considered correction factor so that it goes on to 1G basically. So we can consider that as the correction factor. All right. This is how a plant data looks. Okay. So in this plant data, we put it on a motor. I think if I'm not wrong, we have put it on a non-driving. Okay. So motor has two ends, non-drive end and driving end. So driving end is driving something on the other side. Non-drive end is the other part of the motor. Basically. See all the peaks that you are getting, all the frequency peaks that you are getting. So basically, if you have learned about electrical machines or if you have heard about electrical machines, what happens? There are first harmonics, second harmonics, third harmonics, the fundamental frequency. You can all see it from here itself. Okay. So basically, this is how a plan data looks like. So we got it from the plan. Okay. So before we go on to future improvements, basically, yeah. So basically, we can talk about future improvements also. So we have faced with data loss issue. So data loss means the connection abruptly stopped in between, and since it stopped in between, we could not get the complete data. Okay, so we have to work on that. So we are working on a storage location or a flash memory. If we can build into it, so it can have the data. If it was unsuccessful in sending the data, it can store the data, and then when it establishes connection the next time, it can send both the data. The second point is very important, is because how will we come to know which one is a false alarm and which one is an actual issue? See, a false alarm can be like a person can go there and simply just rock the device and say that there is a vibration. How will we identify those conditions? That we have to come to know. This still we are in the studying phase. How we can do that? Improving battery life is always the concern for us because we are running on AAA battery. So the longer we make the battery expectancy, the better the product. And improving data security. This is a very concerning area. We are sending our data to an intermediate server location. We cannot send the data directly to the Google Cloud platform because there is very high traffic. Data sending can fail or anything can happen. Okay. So instead of that, what we are doing is we are sending it to an intermediate server. That intermediate server is very prone to attacks. Okay. So we have to improve that also. Okay. So now let me show you a very interesting site that I have found, and it's very helpful for me. Okay. So this is what we call as WOKB. Okay. So anybody has used this site? Anybody? No, right? So basically, this is very interesting because if you don't have the resources to for a ESP32 or any other controller, Arduino or any other controller or sensor, you can simply use this website. Okay, this website you can simply use to simulate. You can code your project and you can see the simulation. Let me start it with a classic LED program, basically. So basically what I have done, this is our ESP32. We have connected two LEDs to it. There are two output pins, GPIO pins, D22, D23, and we have connected our LEDs to it. Okay, so what I have coded on is basically on RTOS, so real-time operating system. See in industry you can always use Arduino coding also. That is based on embedded C++ itself. But we try to avoid Arduino and we try to follow free RTOS more often, or RTOS for that matter. Okay, so simply if we start the simulating, you see the two LEDs are glowing at a particular date. We have given a delay of 500 milliseconds. Here we have given a delay of 500 milliseconds, and it is the LEDs are glowing. So a simple change we can make here. So instead of writing it here, if we can write it here, what will happen? You see in the that it glows one after another. If I'm not wrong. Yeah. See, it's that simple to code it basically. Okay. So this is basically a simple code. Our LED code, everybody knows that, and you can do lots of experiments with it if you are interested in this. All right. Then we move on to something called as DHT sensor. Here we don't have the so in our data sheet we use the SHT21 sensor. SHT21 is from Sensiron company. So that is a temperature and humidity sensor. But here to automate it, there is a DHT22 sensor that is given. Okay. So basically this is the DHT22 sensor. This also gives the temperature and humidity of our temperature and humidity. Of course, since this is not a real sensor, it will not give you the real product, but real answer. But you can simply test if your code is working or not. Okay. So if we do this, I have connected it to an LCD. I have used I2C communication for it. Our device in our vibration sensor, we have used SPI 4-line communications for it. Okay. So you see, this is the temperature that is showing. It will show you the humidity also. It will show you the temperature in Fahrenheit also. That's how my code is written there. So this is humidity. This showing. So one data is finished. This is the next data. So data is incremented by one. So basically, you can make that whole code within minutes. Basically. So yeah. So this is one more example where you can see this as well. Now for the important part, here again we have used sensors IIS 3DWB. Okay, in our vibration sensor we have used the accelerometer IIS 3DWB. That is from ST Microelectronics. Okay. Here we cannot simulate that because they haven't included that product here. Instead, we have an MPU 605. So with this MPU 6050, you can actually emulate it. But again, this is with I2C and we have used SPI 4-channel communication. So basically what I have done, I'll just explain the code a little bit, what I have done. So basically, I don't know, anybody knows the concept of a semaphore? How it works? In FreeRTOS, anybody has worked with? No, right? So basically, then I'll just explain it a little bit. What happens is in semaphore is basically there is a handle. Okay, so basically handle means there is a common resource, and there are multiple tasks that are trying to take that resource to work on it. Okay, so semaphore, what happens? It has to call the semaphore handler. Handler it will call, and if task A is taking the semaphore, that means that resource is only work when task A is whatever task A is telling, that resource will do that. Once one task A releases the handle, semaphore handle, then task B can take the handle. So basically, shared resources can be like taken by every task once they call the semaphore and then they start. So basically what happened is I'm getting the temperature and the sensor detail. Sensor detail or get accelerometer value. This is again a triaxial sensor. So basically it will give you 3-axis sensor detail, sensor information here. Okay. So basically what happens is first it takes the first semaphore will be given to the acceleration and the temperature. So the sensor first will gather the data. Okay. Then it will release the semaphore and it will give it to the LCD. LCD will then take the semaphore and then it will display the results. So basically that's the gist of how this code is written. Basically you can go for it. This will be available in GitHub or anywhere you can go into. This is basically publicly available, this code. So once I start the simulation. So basically you will see this is the MPU 6050, the temperature you can see temperature will not be okay. But you see here, this is very interesting. You see 9.8 it shows here in the Z axis. Okay, why is it 9.8? Can anybody tell me here? Huh? Sorry? Can you please speak up? Acceleration due to gravity. Very correct. So what happens on the z-axis? This sensor is being acted by the acceleration due to gravity. Basically, that acceleration is shown by this accelerometer itself. So remember, I told you in our sensor we had to do an offset calibration. So what is that offset calibration? Basically, to bring all these values to zero, we had to do this offset calibration. So what we did was we take 128 samples of data. 128 samples of data we took the average and mean out of it, and then we subtracted it from the mean value. From every value that we are getting, we are subtracting that value. So you see, if you take the mean value of everything, you will get 0, 0 and 9.8. So if you subtract it, basically you will get all zeros. So now your sensor is ready to take the actual value. Okay. So this was very interesting. We actually fumbled in this part at before, but you learn from your mistakes itself. So we did this, and actually we were getting a DC offset of 1G basically. This is actually 1G. 9.8 means 1G. So basically we are getting an offset of 1G, and now we have removed it, and it's working fine now. So basically, this was part I wanted to show. This has been very helpful for me. This remote week, what I have seen. So if you don't have the resources then and there, and you want to test something out, you can simply use this. So I think, I think I have completed everything. To have any questions, I will be happy to take it.
Sir, I have a question.
Yes.
The sensor you have used inside of MQ62. Can you tell me about that sensor?
Okay, so that sensor is from ST Microelectronics. That name is IIS 3DWB. Okay, so that is the same thing as this MPU6050. It's a triaxial sensor. Triaxial sensor means it has X, Y, and Z axis. It will give you the vibration in X axis, Y axis, Z basically. And we have used another difference from this MPU is we have used SPI 4 channel. So SPI 4 channel, I guess if you learn in your ECE classes, you will get to know what is SPI 4 channel. The serial peripheral interface we have used, and here they are using I2C communication. Okay.
Sir, then which one is better?
See, again, that depends on your product. Okay, so that depends on your product. So we wanted to use that because that has a better accuracy. We found out that IIS 3DWB has a better accuracy than any other sensors that we could find. Actually, kind of in Tata Steel, most of the sensors that we will find will be from STM. Mostly you will find it from STM. Basically, every part basically, because STM has made a place somewhere. Okay, that they have created a benchmark basically. That's why we trust that product. Okay, like how you always buy, one product, like you favor that product somehow because you continuously used it and now you are comfortable. So similarly, like that, we think about using.
Okay.
So any other questions? I'm happy to take.
Thank you, Mr. Monak Majumdar, for your uh, very interesting lecture. And I think all the participants have learned a lot from their PPT and their knowledge. So this is a very wonderful session. Now from tomorrow, there are two sessions. Tomorrow session is both sessions are on online. One Dr. Saha from IIT Delhi. So currently he is in Germany, so he agreed to take their session online in online mode, and another one first session from 9 to 11 is patent expert. So they teach about what is patent, how do you go through any patent, any product patent or any idea patent. So I think that session would be also very interested. So now I request Ayush Agarwal, please give the memento to the our today's speaker. Sir, please. You can, no problem. Photographer.
So, a small gesture for your colleague. So let's miss yesterday's lecture because of with some period work commitments. We'll catch. So that is that for those second